Hi, it's Mr. Benson here with a quick video for the next topic, which is sketching linear graphs. Now, I always say it's a quick video and usually they take about 15 minutes, but this is actually pretty short, so hopefully it will be less than that. Now, sketching is different to plotting a graph. Now, you've had a go at plotting graphs before. It's probably stuff you've done in previous years as well. And it's pretty simple because you just calculate the y values for each x value and then you plot each point and then you can draw a line. But obviously that takes a lot of time, especially if you're going, say, from -5 to +5, and so you've got to calculate 11 points. But you don't actually need to do that. We're dealing with linear graphs, and so the whole linear part means that they form a straight line. Now you only need 2 points to define a line. And so sketching is all about finding those 2 points, and how you do that depends on the form that the equation is in. Okay, the first one is when your equation is in standard form, and this is called the gradient intercept method. And what you need to do when you're thinking about this method is you need to understand what the parts of the equation mean. So you've got to remember that the 2 here is our gradient, and the 1 is our y-intercept, and the gradient is m and the y-intercept is c. Now, we start off with our y-intercept. Now that's the easiest thing to find in this form. It's the easiest thing to understand. So in this case, this is just 1. So all I need to do is go over here to my y-axis, because it is the y-intercept. I go to the point that corresponds to 1 and I put my first point there. Now, the next thing I do is I need to think about what the meaning of a gradient of 2 is. So my gradient is 2. Now, I can always write this as a fraction, so I could write it as 2 over 1. Now, gradient is rise over run. So if I've got 2 over 1, that means my rise, the amount I'm going to go up or down, is 2. And now it's positive 2, so I'm going up. My run is 1, and it's always 1 to the right, so it's a positive value. So from my starting point here, I move 1 to the right, and so I get to this point here, but then I move 2 upwards. Don't know why that menu popped up, and I get to this point here. Now the coordinate here is at 1, 3. Now that's important, and I'll explain why in a minute. So now I have 2 points, and so all I need to do is to draw a line through those 2 points. Now you'll have to excuse me because I'm doing this freehand on my tablet and it's going to be hideously wonky. Yeah, see? Actually that's not too bad. So you will use a ruler, of course, as that's what you do for drawing straight lines. So all you need to do when you're sketching is find these 2 points, the y-intercept, which is really easy, and then we use the gradient to find the next point. So we go across by the run and we go up by the rise, and we mark our second point. Now, talking about the gradient here and the rise over run, if you ever get a gradient that's a fraction, so for example, I'll sketch another one on these axes. So we've got something like y equals 2/3 x minus 1. Well, when it's in this form, this is actually really easy. So I start off again with my y-intercept. My y-intercept for the second equation is -1, so it's going to be down here. And then my gradient is 2 over 3, so my rise is 2 over a run of 3. So I'm going to go across to the right by 3, and I'm going to go up 2. And so I end up at this point here, which is at 3, 1. And again, I draw my line, or I rule my line carefully through. Now, there's a mathematical way of thinking about this as well. Now, I'm just going to stick with my first example here. Now, with my first example, I know that c equals 1. Now, my first point is on the y-axis, and on the y-axis, x is 0. So my first point is at 0, 1, or generally it's at 0, c. Now then I have to go across by the run and up by the rise. Now in this case my gradient was 2 over 1, so I was going across 1 and up by 2. Now I'm adding 1 on my x-axis, so I'm going across 1, and then I'm adding 2 on my y-axis, so I go up to 1, 3, which is the point that we figured out over here. Generally speaking, what we do is it's 0 plus the run and c plus the rise. So that's a mathematical way of figuring out where the second point is, which will always work as well. The next one, the next technique that we'd like you to use, and the reason these two techniques are important is they actually need you to think a little bit about the meaning of the equations. But the next one is what we call the x and y intercept method, and it's best for when your equation is in the form where you've got your x and your y on the same side. Now what we mean by x and y intercept is where the line crosses the y-axis is the y-intercept, and where it crosses the x-axis is the x-intercept. So the way we find those is we've got to think about the values of x and y on those lines. Now on the y-axis here, on this whole line, this line is where x equals 0. Now along the x-axis, the horizontal axis, that line is where y equals 0. So to find the y-intercept, we let x equal 0. So we replace x with 0. So 3 times 0 plus 2y equals 6. Now mathematically this is always pretty easy because 3 times 0 is 0. So we're just left with 2y equals 6. Don't know why that didn't work. And if 2y equals 6, then y equals 3. So all I do is I go onto my y-axis and I mark 3 there. That's my first point. Now to find the x-intercept, let y equal 0. So I go 3x plus 2 times 0 equals 6. So again, the y term disappears completely. 3x equals 6, and so x equals 2. And so I mark my second point here at x equals 2, and I carefully draw a wonderful straight line through those 2 points, which that was, trust me, and I've sketched it. Now, there is one problem with this, this technique, and the problem with this technique is that it doesn't work for equations where the y-intercept is 0. So say we had something like, I don't know, 2x plus, that's terrible, 2x plus 3y equals 0. That's meant to be a 0, it's deformed. Right, imagine that's a 0. Now if we get that and we were to use this technique, then what we would find is that the x-intercept and the y-intercept are both 0 because the line goes through the origin here. Now we don't have enough points to plot the graph with because we've only got this one point in the middle here. So you've got two options. You can rearrange it into the standard form, or you can use another technique that I'm going to show you, which is a bit sneaky because it doesn't actually require you to really think about the meaning of your equations at all. But it's a good technique to use if nothing else is working for you, and it's the one you actually will get taught if you do further maths in year 12, just because it's a nice, simple, quick solution. So moving on to the sneaky way they teach you in year 12. Now what all you do with this one, because remember we only need to know 2 points, all you do is you just choose 2 x values from your domain here. Now I'm just going to choose 0 because that's a good place to start, and 3 because it's over here as far across the graph as I can go. Now the wider your graph is, the more accurate it would be. In fact, if I'd gone from -3 to +3, arguably that would be an even more accurate graph, but this'll do. So all I do is I let x equal 0 and find out my, basically I'm finding my y-intercept in this case, which I've done on the previous page, but I'll do it again anyway. It's 3 times 0 plus 2y equals 6, y equals 3. So I have my first point there. Then I let x equal 3 and I substitute that into my equation. So 3 times 3 plus 2y equals 6. So 9 plus 2y equals 6. Use your algebra skills that we've been practicing. I'm going to take the 9 onto the other side of the equation. 2y equals 6 minus 9, which is minus 3. Y equals minus 3 over 2, or minus 1.5. So when I'm across at x equals 6, my y value is going to be down there at minus 1.5. Then I've got my 2 points and I can just neatly sketch through those. Hey, I'm getting better at this. So 3 ways that you can sketch linear graphs. The first 2 are the ones that you'll really be expected to show most of the time up until year 11 and 12. The third way is definitely a good way to use if you're not being asked to use a particular technique. And certainly if you, like I've said in the previous slide, if you've got that situation where you're in the ax plus by form and the y-intercept is 0, so you don't have a second point to plot, you can just go and find a second point this way.